Hello to everybody. My name's Miles Seddon. My son sails in the Terror Fleet. I'm a professional sailor by trade. So I've been playing around with meteorology. I'm a professional navigator, so I've been playing around with meteorology for the last few Volvos. I was with Matt Frey in the last edition and done quite a lot of multi-hull sailing on mod 70s like Fado, bits and pieces on Massif, foiling trimaran. So a bit of variety in there, most of it ocean sailing. So weather is a key part to that. So I'm going to talk to you guys, talk to the other guys, the younger kids, about weather forecasting and where to go and find decent weather forecasts. I'm going to talk to you guys about sailing wind. We'll come back to the forecasting area, but I think if I give you a bit of a grounding on the kind of wind, what wind is really, and how we can understand what's going on in our local area, I think that's as powerful as any kind of weather forecast. So I'm going to start sharing my screen. Hopefully that'll be up. So there we go. Sailing wind, the sort of interesting, boring bit. Right, let's kick on. So what is wind? So wind is just movement of the air around the earth. So air is a fluid, albeit it's about 1,000 times less dense than water, but it still behaves in a very similar way, and it flows around the earth's surface and the upper atmosphere, and it's just trying to avoid the obstacles that are in its path. And we have high pressure systems and low pressure systems. And in the northern hemisphere, the wind flows clockwise out of a high pressure system and gets sucked up anti-clockwise into a low pressure system. And what we have at the moment is with a big high pressure system sitting out to the southwest of us. That gives us very stable, light winds, not many clouds around, so the conditions we've got at the moment. Whereas at the weekend and all through last week, we had 3 low pressure systems banging on our door. And they were quite intense lows, so we had a lot of storms with those, a lot of weather fronts, a lot of interesting weather, whereas a high, there's a lot less going on. In the spring and the summer, a high offers a lot of potential for sea breeze development, so we will come on to that. So if we look at this little diagram I've got here of how the wind flows out of a high and into a low, I want to take you to basically a synoptic weather chart. So this is what a weather forecaster always goes back to. This picture tells you 1,000 words. If you know what you're looking for, it really does tell you everything that's going on. And it tells you something very important. This forecast is for the gradient winds. We call them the gradient winds. They're up at about 500 meters above the Earth's surface. And these are the winds that are blowing around from high to low. There's not a lot of things for them to bump into up there. They don't really get affected too much by the Earth's gravity, the Earth effects, the effects of the land and the sea. So these are the winds that are just kind of blowing around. And this is what's being forecast here. This isn't what's being forecast at the wind's surface, and we'll come on to that. So these synoptic charts are really good. They tell you a lot of information. And if you just go back to that, if you picture that image I've just shown you, this one back in May lined up really nicely with that high pressure, that 1029 high, and that low pressure there. You could see the winds coming down between the two of them, so they were spiraling out of the high clockwise and into the low anti-clockwise. And there's that image on its side. So it actually did a really nice job of validating a bit of textbook theory with a bit of what was going on in the real world. So there you go, air just moving around, the wind is just air moving around the earth, trying to get from A to B and trying not to bump into things. It's quite lazy wind. It just tries and finds the path of least resistance wherever it goes. So if it's got a chance of flowing over some nice flat sea, it'll do that rather than flowing over a horrible, rough, rugged forest. And that's something locally to always have in the back of your mind. So that leads nicely on to what I'm going to talk about next. So remember me saying there was the 500 meter gradient wind, and that's what's in those synoptic forecasts. And that's what weather forecasters are really interested in going around the world. They want to know what's going on the gradient wind. As sailors, we want to know what's going on at the surface, and that's sort of top 10 meters. And that's what grid files, the weather files that we use for forecasting, are based on. They quite often come down to the 10-meter wind, so it's really useful for sailors. So this is what I term a wind fact. This is surface drag. So let's assume that we've got a coastline and we've got the sea next to it. It looks very much like sort of the mainland shore here and the Solent. And we've got a gradient wind blowing along it. Well, in the forest, we've got a lot of trees, and trees are rougher than the sea, a little bit like sandpaper is rougher than glass. So if you run your hand over a sheet of glass, it's very smooth, there's no real friction. If you run your hand over sandpaper, there's loads of friction. So the same is true for the wind as it passes over the Earth's surface. Less friction over the sea, more friction over the land. Now, in the northern hemisphere, as that wind comes in contact with the surface friction slows it down and it turns it to the left. And that shift to the left over the land is about 40 degrees and only about 15 degrees over the sea. And sort of if we've got a 25-knot wind blowing, a gradient wind at 500 meters, you can expect that to be reduced to about 10 knots over the land and about 15 knots over the sea. So that's why over the land it's always a lot calmer and a lot more left, and over the sea we've just got more wind flowing. But those are important things to kind of get into your head. You know, typically 25-knot gradient pressure comes down to about 15 knots over the sea, and it turns left about 15 degrees. And that's why you'll always see the clouds are blowing at a slightly different angle to what we see when we're standing on the surface of the Earth. Because the wind gets turned to the left. And obviously in the southern hemisphere, if you ever go down there and you're sailing, everything gets turned on its head and it rotates to the right. But surface drag is a very, very important part of sailing. And this is something that goes on all the time. And kind of the slides I'm showing you now are assuming no thermal effect, no sea breeze effect, because these are the underlying factors that happen regardless of that. So regardless of any sea breeze, any thermals, this is going on. It's always going on. It's a fact of nature. Surface drag is really important because if we think again about our mainland coastline, our Lymington coastline, if we've got a gradient wind that's coming in from west-northwest, which is fairly typical here, a lot of you might think that a southwest is least typical, but actually the gradient wind is probably west-northwest. The land wind, as you can see, is 40 degrees turned to the left and reduced. And the sea wind is 15 degrees to turn to the left, but reduced not quite so much. Now you can see that these arrowheads are diverging here. So this is what we call coastal divergence, or this coastline is a divergent coastline. And this means that the wind is turning on land and decreasing, and offshore turning away as well. So we get this divergent zone with lighter winds that bend in close to the shore. So on a day in Lymington where you haven't got a sea breeze developing, or very early in the development of anything, this is a classic situation. So lighter winds along the coastline. Equally as the breeze is dying out as well, lighter winds along the coastline. And it's sort of, this plays into your coach's hands. I'm sure many of you have been told, land on the left upwind, go left. And this is the whole reason for it, because on the opposite coastline, you've got convergent winds. So think of this as being the Isle of Wight now. We've got the same wind, but we've got the two winds coming together, because as that wind flows across the island shore, it turns left by 40 degrees, and the same is happening with the winds coming across the Solent. They're turning left a little bit, but they're coming together. These arrowheads are coming together, which creates an area of stronger winds along the shore. So these are always happening. Even when we've got a sea breeze trying to happen, these sort of effects are still going on underneath of all of that. And so they're really, really important concepts to have in your head. They apply anywhere you go sailing. And that's why coaches will put that simple mantra into your head: land on the left, upwind, go left. You will find that stronger line of breeze. Obviously, there's all sorts of different things at play, particularly in the Solent. There might be tide lines that you're playing. And tide is extremely important in all this, because if you've got favorable tide, you can, the tide, depending on which way the tide's going and the wind's going, it can be increasing or decreasing your sailing wind by a couple of knots. So knowing where your tide line is can override all of these theories. But in terms of wind, these are really, really important theories. So these are just facts. They absolutely happen the whole time. The next thing that happens, and it's a day-by-day thing, obviously it happens more as the land's heating, so more from late spring through the summer, and we've got cold air, water temperatures, but convection mixing. So a lot of people think that sea breeze just happens because the land is heating and the sea is cold. It's not quite true. It's the convection mixing that makes sea breezes happen. And so it's all about making the air column, making the wind overcome the drag of the surface winds. So it's a bit more of a complex situation. But if we imagine we've got a bonfire here and we light the bonfire and the hot air starts to rise up, and as the ground is heating, the cold air starts to descend down, and this then gets the wind flow moving. Okay, so it's that heating, moving, the old convection sort of thing going, and this creates an unstable air, and that unstable air mass is what drives a sea breeze. If we've got stability in the air column, then we've no hot air, we've no air moving around, and we get no surface wind, and we just have calm areas across everywhere we're sailing. So though we think the sea breezes, well, sea breezes are quite reliable, especially here on our coast, there are different, there are some triggers, and you can see them in the morning of whether they're actually going to kick off or not. Some days you think you're going to have, this is going to be a guaranteed sea breeze. Everything looks set for it, but you actually look out and you realize that it's actually a very still, stable, calm, hazy day, and you think this is just never going to get going because you've got this very stable air, and that stable air is trapping all the pollen in it. It becomes very hazy. It's just very difficult to get going. So so that convection mixing is hugely important to any kind of sea breeze, and I'll come on to talk a little bit about sort of sea breeze around Lymington at the moment and how we can predict them and see them. So this is sort of a classic sea breeze kind of front. What you see here is this sea breeze cloud typically develops around Milford-on-Sea, or just offshore from Milford-on-Sea, and you'll see that in the morning, probably around 9 o'clock, you'll see these cumulus clouds start to build. And as the sea breeze comes in, those cumulus clouds move inland, move inland, move inland, and you get this colder air behind it, and that's your sea breeze coming in. That sea breeze front, those cumulus clouds will go all the way past Brockenhurst by about 11 in the morning, and they'll get as far as Salisbury. So the sea breeze front can get as far north as Salisbury before it dies off and starts to come back again. So it's quite interesting as we get towards next season. If you start to look at a few satellite images and grid files for those sort of things, it's really interesting to see how the sea breeze front can move. And there's some really good, if it becomes more interesting to you, there are some great books on this sort of thing. They're good bedtime reading because they will put you to sleep quite quickly, but they are quite interesting. So I've rushed over it because I'm aware of time, and I'm just trying to sort of more ignite your, is this interesting? And then you can come back to me with questions. I do have a few little bits and pieces. This is sort of you make some note time, because these are the good bits about sea breezes, really. So sea breezes, there is a rule on sea breezes, and that's that they happen in quadrants. Okay, so in this example, it's kind of nicely lined up with Lymington and our kind of directions here. So quadrant 1, 2, 3, and 4. So quadrant 1, which is a northwesterly breeze, is the favoured situation for a sea breeze. So the divergent winds that you would get with that wind direction help a sea breeze to develop, and it'll start on the coastline first, and then that sea breeze by about 2 o'clock will have built to around 20 to 25 knots. So that's when we get the classic pumping southwesterly sea breeze. It actually starts out of a northwesterly gradient wind, so that's up at 500 meters, we've got a northwesterly, and that then becomes that 20-25 knotter that comes in through the Needles, and a beautiful sea breeze and great afternoon sailing here. Quadrant 2 is slightly less favoured than Quadrant 1, because this is now a convergent coastline, and that convergent wind hinders the development of the sea breeze a little bit. So it ends up fighting a little bit with everything, but usually the sea breeze will still get going here. And it'll establish itself a little bit later in the day. So Quadrant 1, it'll be about 11 o'clock in the morning, you've got a pumping sea breeze. Quadrant 2, it might be 1 o'clock in the afternoon before it gets going. But it's very likely that it'll get going. It'll probably not exceed 15 knots, but it's still likely to be a good chance of a sea breeze when you've got that northeasterly wind. Quadrant 3 is a funny one. You've got the wind coming in already, but it's not going to be, because you've got that wind coming in, it's stopping any sea breeze wind going, any return breeze going out to feed the sea breeze. So it's not actually a classic sea breeze. And what tends to happen in a southwesterly, when your day starts off with a southwesterly, it just turns right and ends up as a westerly and blowing along the coast here. So it's not actually a really good direction for sailing, because the wind becomes westerly, it goes along the coast, and then it just becomes really shifty. So 3 is not a good place for a sea breeze. You get thermal enhancement, but it's never that good. Quadrant 4 is absolutely the worst scenario here in Lymington. You know, usually this is when there's a big high pressure sitting over the land, and nothing ever gets going. It'll fight all day. It'll get to around 4 o'clock. You might find that there's a little few puffs of something going by 4 or 5 o'clock, and then it dies super quickly. So it's really kind of, if you've got a southeasterly wind, and it's a light southeasterly, you're almost guaranteed to get no racing in that day. It'll be a real horror show to try and get anything done. So the top 2, anything with a northeast, northwest in it, probably get a decent sea breeze. Southwest, you'll get a bit of thermal enhancement. Southeast, it'll be an absolute horror show. So that is sort of, again, the golden rule of sea breeze development, basically, is those 4 quadrants. You can take that quadrant with you anywhere on Earth, plonk it down on the coastline, and work out whether you're going to get a sea breeze development that day or not. It's quite funny how often people go to different venues that are orientated on a different coastline, and they don't think about the orientation of the coastline. They go, oh yeah, we'll get a sea breeze, and it's just never going to happen, because it's coming out of whatever is Quadrant 4 on that coastline, and so they're never going to get a breeze development. So it's a really good tool to have in your bag, is just think about that one when you go to regatta, and or you go training somewhere new, and you're sort of light winds start of the season, you're thinking, is the sea breeze going to develop or not? This will almost certainly tell you whether it will or not. There are quite a few useful sites. I explain these to the younger kids. These are the ones that I use daily, and I will take you through them. I'll flick to the web browser in a second. But these are websites that I use daily as my sources of weather. Windy.com is fantastic. It has access to the ECMWF 10-day weather forecast. That's the best weather forecast, best medium range weather forecast in the world. If you were to buy that weather forecast, it would cost you around about £250,000 a year. I know that because in the last Volvo we bought that weather forecast, and that's how much it is a year for that information. It's free to view on Windy, so you know it's a great resource. Windy's also made looking at weather a lot more interesting, so we'll dig into that in a second. Here in the UK, we have the Met Office, which in terms of global weather offices is probably the best in the world. I was explaining to the little kids earlier, in 2016, they spent £2 billion on a supercomputer. And in 2022, they intend to spend another £2 billion, though that probably won't exist anymore because of COVID. But they are supposed to be binning that supercomputer and getting a new one in 2022 and spending another £2 billion on that. So weather really is important to the government, and it's important for several reasons. Climate change is one, predicting storms and storm damage is another, supporting the military is another. So the Met Office is basically a world leader in that. So the Met Office website is fantastic and a really good resource for looking at what's happening. The windy.app, so it's not windy.com, but windy.app. That's an app on the iPhone or Android. I think it's about a £20 subscription a year. But if you're a sailor, I'd say that's well worth it because it has, again, it has access to the ECMWF weather model. It has access to the French Rome weather model. And I'll explain those in a bit more detail in a minute. But that's got some really useful features in it as well. I'm sure most of you know about weatherfile.com. That's the live weather observations on the Lymington Star platform and at Hurst Castle. That is invaluable at validating any weather forecasts you get. So you might have a weather forecast that says it's going to blow 7 knots, and you go and check Weatherfile and it's 22 knots. It does happen. So it's really worth checking Weatherfile just to make sure that things are happening as they are forecasted. We did have a training session in the summer with the Terrors where we all got down to the car park. It was blowing 28 knots from the south, and everybody was looking at me like, what on earth is going to go on? We can't possibly go out. Let's cancel this. I said, let's give it half an hour, because I could see that this was a cold front coming through, and I could see that in Christchurch, through weatherfile.com, I could see in Christchurch it had already gone back to being 12 to 15 knots from the southwest. And so we waited half an hour, and sure enough, it was 12 knots from the southwest, and we had a beautiful sail. So seeing those live observations just validates everything that's going on. Finally, the Hydrographic Office, they're just a provider of the tides. It's always useful to see what the tides are doing. It'll give you an idea of what the tidal streams are going to be when you're out there. As I say, tidal streams can have a massive impact on the sailing wind. Get on the wrong side of a tidal flow, and you could be 2 knots less wind than you are on the other side of it. So it's pretty important to get that kind of thing right. So using those sources and those sites is something that I do daily. I probably spend 10 minutes, half an hour, probably daily looking through those sort of things. And if I'm going sailing, I'll probably check that 10 minutes before we dock off as well. So I'm just going to go to windy.com. So this is Windy. They've done a fantastic job of making things look pretty, really. So we've got a big high pressure sitting over us at the moment. This is now. So this is why we've got all these nice clear skies, light winds. It's pretty strong winds off Cap Finisterre here at the moment. But you can see the surface pressure. So if you think about that being a high pressure, so clockwise winds, so we've got northwesterlies, westerlies, northwesterlies, northerlies sort of blowing around at the moment, which is exactly what, if I go to weatherfile.com, exactly what we've got here. Light winds coming out of Lymington River, just blowing light northerlies. So really important when you look at these things is just to make sure you're comparing apples with apples, really. So if I click on somewhere here, so you can see this wind, this little thing comes up, and it tells me that I'm looking at 5 knots of wind. So that's what that ECMWF forecast is forecasting, 5 knots of wind. If I go to Weatherfile and I check my settings, I changed these earlier. So if I'm looking at meters per second, did it? Yeah. Let's have a look. I'll put that in. Sorry, kilometers per hour. There we are. Kilometers per hour. It says that we've got 8. So we've got 5 knots forecast, but 8 here. So make sure that you are comparing apples with apples and that you've got this set to knots as well. It's so frustrating. It does it nearly every time you log in. Fortunately, on the it seems to be on the iPhone app, it kind of remembers your setting. but it doesn't always do it on the website. To go and check that and make sure you're looking at knots, because at least then it's the standard unit measurement for all weather forecasts. So that to me is fairly critical. But this is a hugely powerful page. You can look at the live graphs of what's happening, what has happened, and you can then compare this with the weather forecast. If I go to the Rome here, you can compare it with the weather forecast of how it's lined up over the day. So in Windy, you'll see down here, sort of mentioned a few times, different weather models. So the ECMWF weather model is, as I mentioned earlier, probably the most accurate medium range 10-day weather forecast in the world. That's produced in Reading. The ICON weather model comes out of the German Meteorological Office. Again, really good, accurate, free 5-day weather forecast. And the Rome model here is the French Met Office's model. And this is extremely high resolution. And this only goes out to 2 days. So this 10-day model, the ECMWF, I think it probably ends up with a data point about where my cursor is here, and probably another one off cows. Whereas the Rome weather model probably has 100 data points between Hurstcastle and cows. So the Rome model is taking in, is looking at much more detail about what's going on in the Solent. The ECMWF weather model, it assumes a single uniform height of the land around the world. I think it's about 15 meters. The Rome weather model has a really detailed topographic model of the UK and France. So it's able to detail all the estuaries, the fact that it's slightly higher land over toward Brockenhurst, the higher land over the Needles and things like that. So land effect comes into this model. This model also has built up areas in it. So it looks at where we've got towns and how much the heating effect is on those towns with all the concrete versus the heating effect on the forest versus the heating effect over the sea. So it becomes much more detailed in that. And obviously if it can do heating effects, it can start to model sea breeze. So where with the ECMWF model, which is quite long range, and you get some idea of where the sea breeze might develop, the Rome weather model only runs out to 2 days, but it will give you a really detailed and accurate sea breeze model as well. So that's a really, really useful tool for when you're going sailing, is to just be able to see where that sea breeze is going to build. I'm a big fan of the Rome weather model. I know that the guys at INEOS have been using that as their model, their go-to model of choice for sailing in the Solent. It's been extremely accurate and a really good tool to have. So I think it's an important one to look at. The other thing that's important is the Met Office. So I said to the kids earlier, basically, if you've got the iPhone weather app or any default weather app on your phones, or your parents have, delete them immediately. They're rubbish. They're not worth it. They are about as useful as your grandma's socks at telling you what the weather's going to be. If you get rid of them and get Windy on there and get the Met Office app on there. The Met Office is a really useful resource. Not only does it give us what I call the mum forecast, which is it going to be sunny and is it going to be warm or is it going to rain? It gives us the sailor's forecast down here, which is going to be what the wind is doing and what the gusts are doing. It's not great. The website's not great at showing you a sea breeze, but it will, if you think about the sea breeze quadrants, it will pick that detail out for you. Where it is also really good is it, somewhere on here, there is a rainfall radar. Here we go, rainfall radar. Won't be much going on. But this is a live radar of what's going on with the rain. So if you've got weather fronts coming through your racing area, this is really good to just see how those are moving, how they're progressing, because fronts move at different speeds to forecast. So a really good tool for that. So I'm going to stop there because I've gone on for quite a long time. Let's open it up to some questions. And if any of you got anything else, you want to, we're recording this so you can watch it back. But if you ever got any questions or you want any help with your weather, give me a shout, get hold of me through Hugh, or anybody at the club, and I'm happy to help out and go through things in a bit more detail for you. So I'm going to stop sharing that and open it up to questions.
Okay, well, I've got a question. Miles, it's great to get your sort of view of what all the various different websites are and can provide us. I suppose when we're looking at what goes on for us in the Solent, it's and down at this end of the Solent, how much impact do you look at what the actual tide state is, and how much and where the tide is relative to the heating of the mud flats that we get? Is that impactful to us, or is that just something that is insignificant?
I think the tide, the heating of the mud flats probably isn't that. It'll have a significant effect at early morning and evening when you're not racing. You know, it's one of those things. As an offshore sailor, you might look at as a dinghy sailor, it's probably not that critical. Probably a bigger factor at that time is kind of the impact that the tide is actually having on you, because if the winds have got that light that you're worried about the impact of the mud flats heating, the tide's probably going to have more impact on what the wind's doing than the mud flats are. So I'd be very, very conscious of what the tidal flows are. There are, if you do a Google search for, I think, Solent tidal streams, there are some very low resolution charts of what the tides do around the Solent. They're pretty useful if you've got nothing else. There's also quite a good YouTube animation that the ABP, so the ports in Southampton, did for the tides around the Solent and how they flow in and out and where the max flow and min flow is likely to be. It kind of, if you get a hydrographic chart, you can kind of work it out because it's just going to take the path of least resistance. But it's interesting to see those flows, sort of how earlier they turn along the shores and things. And that all has a massive impact in your sailing wind. We often forget, or we take a weather forecast, and we often forget that weather forecast is for a fixed point on the land. It's not for a fixed point on the seabed. It's not the winds that we are feeling on our sailing boat. So it's quite an advanced concept, but if you imagine a sailing boat on a flat, calm day, and say you're just at anchor in the middle of the Solent, flat, calm day, no wind, but there's tide. So if you're at anchor, you're not going to feel any wind whatsoever. If you lift up your anchor, you're going to start drifting on the tide. And if you're drifting this way on the tide, you're going to feel wind coming from here. So it's called tide wind. And that's a component that we have to remember is in our sailing wind. So if you've got the tide, say the tide pushing you this way, you've got wind coming from this way, and it's equal in strength and opposite in direction to the tide. So if you've got 2 knots of tide sluicing you down the Solent, you've got 2 knots of wind coming in your face. That is either going to add to your wind or take away from your wind. So understanding what your tide is doing and when the tide's going to turn it can have a big impact on what side of the course you're going to end up on, and how your strategy for the day. So that's probably a bigger impact.
Hi, I have a question.
Yeah, go on.
Yeah, I was just wondering about the different types of cloud forms and what they mean, because I know I was taught this in like year 7 geography, but I forgot it. So if you could just give an overview more specifically towards like sailing, that would be really helpful.
Right, okay. It's not something I've got to hand just now. Well, I've got something to hand. Basically, just trying to think if I've got anything that I can show you very quickly.
Whilst you're doing that, Miles, Ewan, what's your second name and what boat do you sail?
My name is Ewan Plowden Wardlaw, and I sail a 29er.
Thanks a lot.
Thank you.
I'm just going to keep looking. Dun, 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 dun. They're all on my server and they're just difficult to get to now. Right, hold on. Oh, I can get there.
Whilst Miles is looking for that, I've got a book here that might help everybody. Hang on. If you're into looking at clouds, then a book you need to buy is this one. Oh, let me just turn my background off, and that'll be a little bit easier to see. You need to buy that one. Instant Weather Forecasting by a guy called Alan Watts. And this book is very good at just giving you a picture, and then what it means and what the influence of it is. And it's just great for trying to get your head into, look out the window, see fluffy clouds on there, and then what to expect. And we all know that means, hot air rising, etc., but it then just helps you try and make that association better. And it's something that I'm really keen to try and help. The stuff we're doing here with Miles is fantastic, and the more we can do stuff like in the morning, look at the forecast, and then look out the window and see what you've got, check the starting platforms, check Hurst, see what the wind is, and then oh, the clouds is this, oh, the wind there is that, oh, okay, I've had a look along the coast. And one of the other things that I actually find useful too is there's quite an interest, and Miles probably told me there's a better one, but there's a website called Windicator. And Windicator basically is a sample of all the different weather stations in addition to Weatherfile along the coast, which gives you a nice view of what all of the various different anemometers are showing. How are you going, Miles?
So this is quite a useful, sort of a quick guide to your different types of cloud. Okay. Yeah. So, on the left, you've got...
we just need to share your screen.
Oh, am I not sharing that? Oh, no, hold on. I didn't click that. There we go. Sharing that now, I think. So on the left of that, you've got your nimbus stratus, and you can see that goes up quite high, sort of the mid-layer. It's starting to get to the mid-layer clouds. If you look at the top to begin with, so the high clouds at the top, the cirruses and the cirrostratus, they just have a really wispy, high-level clouds. They're not really they're not affecting you at all. In sailing, we're getting down to the clouds, down in the low clouds. Stratocumulus doesn't have a huge amount of effect. It does when you're crossing oceans, you get bands of it. But the ones that you'll sort of see typically around here on a sea breeze development and coming into the coast are the cumulus clouds. And as you see those develop into big storm clouds, they just start going up and up and up into the sky and become cumulonimbus, and then you get massive storms with them. Over on the left, the nimbus stratus, they're kind of your more dense rain clouds. The important thing with clouds really, or the most important thing from sailing point of view with clouds is, let's just see, this one, which is kind of a quick guide to how you deal with them, which is basically, if you want extra wind, get on the front of it, and if you don't, sail away from it. You've got your general wind direction, and if you can picture your cloud inside of that general wind direction, you are going to have strong winds from it blowing on the front of it, and these diminish all the way around the side to the back of the cloud, where you're going to have the light winds where the cloud's sort of sucking up from. So that's typically what you will find. And if you sit on a beach for long enough, and people sit on a beach and think, oh, this is boring. But if you sit there and you watch the clouds come in, you can actually start to see these things happening. You start to see them on the water as well. So that's quite a useful, it's quite a good use of a bit of time, is just going down to Milford and sitting on the beach and watching clouds come in. Sounds incredibly boring, but actually, if you start to play the game of, is that going to be a lift or is it going to be a header? You'll find that you can actually start to pick things quite nicely from the cloud, where it is and where you're positioned on it. And that's what the good trimmers are doing. They're looking at where they are compared to a cloud position. When I say good trimmers, about 4 in the world are looking at where they are on a cloud line and able to tell whether the next puff is going to be a lift or a header. The rest of them just guess. Fact.
Cool.
All
Thank
right,
you.
I don't want to go into too much. I mean, as I say, there are some really good books written by people who know a lot more about clouds than I do. And there are some really simple guides. In fact, there is a really good one, just to general clouds. There's a really good guide online, and it's like a wheel. And you can just print out this cloud wheel, and it tells you everything about that cloud and what it's likely to do. So that's quite a useful one.
Well, Miles, has anybody else got any other questions? A big thanks again to Miles. Any further questions?
I'm just going to throw one more thing in. Whilst we can't do weather forecasting for virtual regatta, if the wind's coming off the land, it's very shifty. And if the land is on the left, it actually pays to go left in virtual regatta. So they have actually modelled quite a lot of the wind in there. So it is worth knowing those basic facts.
And what about if it's in the southern hemisphere?
Oh, well, it's all back to front.
So if you're sailing,
just like the southern hemisphere in general.
yeah.
Yeah. So do remember those things. You know, remember the venue you're sailing at, as Hugh says, because everything you're thinking about could be turned on its head. So it is important. The other thing I just want to throw in there is when we do get back to sailing, please have a look at some of those websites we put up there and have a go at making up your own weather forecast. Yeah, because it's really good if you can come to your coaches and say, actually, I think that we're going to see 15, 18 knots out there, and we'll have a better wind band over on the left or the right, or along the coast or offshore. If you can start thinking about that kind of stuff and challenging those ideas and building up in your own mind how you do that weather forecast, and also think about how the tide is going to impact on the wind, then it's going to be a lot easier for you down the line. You're going to have big advantages on just going to other venues as well. You know, you guys going sailing at Weymouth, you know, it's super easy to forecast what's going to happen at Weymouth. It really is. There's no black arts there. It's really, really simple. All sorts of different venues. If you can start getting in your head in Lymington and validating with your coaches what they think the weather's going to do, then it's going to make your lives much easier going to other venues.